Yeah, all right. And if the video does stop in at any time, just be able to rejoin using the same link. So I'm sure you can see what's on my screen, and it says simplify and express. So there's this expression here, and they're telling us it must be in the form. It must be in the form p uh, root 3, where p is a rational number. It's supposed to be p is a rational number, or p is rational. So now, what does that mean? It just means that your p that you get must be able, so p being a rational number means that it must be expressed in the form a over b, where b is not equal to what? To 0. So you have to get into kind of this form here. And so now, as we are going to get to that form, we have this expression here. So we have 1 over root 12. Then what you have there is plus 1 over root 48. Then you have minus 1 over root 27. So what are we going to do here? So what we can do is observe that you want to get to this form where you have a root 3 somewhere. So can I try to get a root 3 from these that are here? Can I try to get one? A root 3 is what I'm going to try first of all. So I get a root 3. So how do I get that root 3? I observe that 1 over 12 can just be written as, so I can write that as 4 by 3. Then I can write this plus 1 over root 48 can be written as 16 by 3. Are we together here? When we multiply 3 by 16, we do get 48, right? Yeah. Then minus 1, of course, over root 27 can be written as 9 by 3. So I can obviously see now that at least I'm getting that root 3 somewhere, like that. So now, what next do I do here? Just say 1 over, so my root here, I can separate these because it's multiplying. So if I say root 4 multiplied by root 3, it's going to be the same as whatever this is. Then I have plus, then I will have root, so I have root 16, so root 16 there, then square root of 3 plus, okay, there's a minus sign there, so minus 1 over square root of 9 multiplied by square root of 3. Okay, and this is going to be equal to, so now we can simplify that and see that you just get, what do you get there? So you have 1 over, so the square root of 4, that will be just 2. Then you have root 3. Then, of course, the next part is 1. Then you have square root of 16, that's 4. And you have root 3 minus, then you have 1 here. Then you have square root of 9, that's going to be 3 root 3. So you kind of get this here, this form. So now, what can I do with what I've gotten here? So they're telling me I must have this form p root 3, where that is a rational number. So here, can I simplify this further on? Of course I can. I can actually try to put this into a single fraction. So by single fraction, so if you're seeing what is going to be our common divisor, common denominator for all these three, yes, you can respond. Anyone? What's our common denominator here?
I think the same denominator that we have on all the fractions.
Okay, so you have this one, that one there, right? So what is going to be common? Thank you for that response. So when you look at the same ones that they have here, if we multiply here, try to getting a number which 2, of course, is going to divide into it, 4 is going to divide, and 3 is going to divide. Observe that when we use 12, so 12 will be a lowest common denominator for this. But of course, there's the root 3 part here. Such that when I divide my 2 root 3 into this part here, I'm just going to be dividing the 2 into 12, and that's 2 divided into 12 is going to give me 6. Then I'll have a 6 there, then I can work that out. So when I divide here, I first get what? Get 6 there. Divide the other one, I'll get 3. Then divide this last part, I'll get a -4 there. So this is what I have. Simplified it, made into one single fraction. So now, what do I do next here? Okay, I can add. So I can add these and then subtract. As you can see, or here you already know that this is just 6 minus the 1 there, uh, of of course, which is just going to give you 5 there. Then you have 5, then you have 12 root 3. So now we want to ask ourselves, are we there yet from whatever they're asking us to find? So observe that you can write this, let me use in white. The value that we found here can be written as 5 over 12, then 1 over what, root 3. So now, is this exactly what we want to get? So it's not really exactly what we want to get, because when you see here, they are telling us that the root 3 must be what? Must be on top. The root 3 must be on top, because then you have a rational number that's there. So, which means here, if I multiply by root 3 in the bottom, and also in the on top there, and in the bottom, that's the denominator and the numerator, you're going to get a value. So I erase this part. Okay, so we continue from here. And you see that when I multiply that, I'll get that will be equal to 5 root 3 on top. Then down there, so when you have a root multiplying by another root like this is the same as, so you have a square root. It's like you're having 3 squared like this. So I know that when I say root 3 squared is just root 3 by root 3. Yeah, like I'm multiplying these two. But of course, we know that the root 3 here can be written as 3 1 over 2 to the power 1 over 2, and you have 2. And these powers then divide, and you just remain with what? With 3. So when you're multiplying this, your value that you get is just 3. So you see that you have 12 multiplied by what? By 3 in the denominator there. Then you can evaluate what is 12 by 3.
36.
Okay, so we have 36 there. So now 36, now you observe that we've gotten the form which they wanted, where we're saying if I write 5 over 36, then I arrive my root 3 there. You see that this p, which they're saying, the p in front is what? This 5 over 36 is just a rational number and is rational as p here, the condition that is given. And I have the root 3 there, which is here. And I conclude that that there is going to be your answer. I don't know if it's clear or we have any questions on this one, but that's how you work out this question. All right, so I guess there's no questions. We move on to the next one. So the next set of questions, they say, without using a calculator, simplify each of the following. Anybody have an idea on what we have to do here? Feel free, just give out your idea, what you think. I know you guys have been
Yeah,
studying. Yes,
I have an idea.
yes, go on.
We'll multiply it by the conjugate of the denominator.
Okay, so we multiply by the conjugate of what? Of the denominator. So now, exactly what you said, but in this case, because we have 1 over, so for the first one, we have 1 over root 5. So when you have it where you just have a root like that, you just multiply using what? You multiply with the same root, what? Root 5 to make free the denominator from what? From the root sign. But when you have a number of which the next set of questions will show us exactly how we'll be multiplying by the conjugate. But for this one, we'll just say you multiply the denominator and the numerator by root of 5, and root of 5. And like that, I see that on top I'll get root 5, down I just get what, 5. And I end here. There's no further place where I can go with this one. And it's the same approach. You see, same question with that part 2 here, where I have 1 over root what? 1 over root 3. But now let's go to 3. Let's go to 3 and we look at that one. So we have 12 and we have root 448 like this. Now here we can simplify it. So how do we then simplify it first? So observe that on top you have you can get a perfect square there, and the perfect square is 4. So you have 4 by 3, then divided by, even in the denominator you can have that perfect square. So you have 16 by 3 here. 16 by 3 gives you 48, and there 4 by 3 gives you 12. So you observe that that is just root 4, then square root of 3, then divided by square root of 16, and then square root of what? Of 3. And there you get this nice thing where you just have on top, you have 2 root 3 like that, and then you have there down, that would be 4 root 3. And you can simplify this. So simplify this, divide the 2 into there, 2 into 2, 1, 2 into 2 there, you get 2. And you just have that to be equal to root of 3 divided by, then you have 2 root what? You have 2 root 3. So you have this here that is going on. And of course, you have the root there. You have the root of which you can actually further on divide, isn't it? Are we following?
Yes, we are following.
Okay, so you have this here. So what step are we going to take next? Can we simplify this further on? Anyone?
I think just leave it like that.
Okay, somebody says we just leave it like that. Anyone else?
We can multiply again with the denominator.
So we multiply with the denominator. What are we multiplying exactly by?
The 2 square root of 3.
So we multiply by the 2 square root of what? Of 3. So when we multiply here by 2 square root of 3, there 2 square root of 3, and we're going to get here down, you just get, you have 2 multiplied by 3, and on top there you just have also, okay, so that is 4, not 2, but you get 4 multiplied by 3, then there you have 2 multiplied by what? By 3. And of course that just simplifies to us having you can see there, okay, you can divide the 3's here, like they just go, then you have here 1 and that, then you see that this just goes towards to half. So this is what we get, and this is of course the correct answer. Yeah, so this is what you do. I hope you're clear here. Let me just erase this. Maybe it looked a bit messy here. Let me rewrite it. So when you have this 2 multiplied by this 2 here, it gives you 4. Then root of 3 multiplied by root of 3 there gives you what? 3. Then you have that. And we'll just say there's 3 there. Can divide that. Then I can divide 2 into 2. 1, 2 into there gives me 2, and I just get half there. And that's how I simplify that one. All right, unless there are any questions, but we move on to the next one. So the approach is kind of just similar or kind of the same. So we'll do part 5, then I guess you will be able to, part 4, then you'll be able to do the last one there. So root 20 plus 2 root 24 minus root 80. So here, what perfect square can I get that in 20? So for 20, I see that when I multiply 4 by 5, I get that there. I get 20 plus 2 in 6. What do I get? I can multiply, what can I multiply for 6? It's 4 by what? 4 by 6, right?
Yes.
Okay. Then for 80, what perfect square are we multiplying?
20 by 4.
So 40 by 4. So 40.
What about 20 by 4?
Okay. So yeah, 20 by 4. Let's say 4 by 20, right? But okay. So observe again that this is just the 20 is 4 by 5. Then you have 4 multiplied by this 4, which just gives us what? 16. So we can say 16 by what? By 5. So meaning here, you can just write that to say this will be 16 by 5. We know that 5 is, 16 is going to be a perfect square. So putting that, I can remove that. That'll be 4 root 5, then plus 2 root 4, root 6 minus root 16 root 5. Then here I get 2 root 5, then plus there 2 by, this here gives me 2, so I have 2 by 2, which is 4 root 6. Then I have minus, that would be 4, then I have root 5. Then these that have the root 5s, I can add, see, this one and that one there. So when I subtract, I just get negative. So here I can write this 4 root 6, then there I get negative 2 root 5. And that's how I simplify this one. So this is how you simplify. All right. If there are no questions, we move on to the next set of questions. Anybody lost? Are we together? Okay, so there are no questions. We move on to this one. So now this one tells us to rationalize the denominator of the following. And now it comes into play or brings into play what the gentleman had mentioned about us using or multiplying by the conjugate in order to free the bottom there, or to free the denominator of the root symbol. So that's what rationalization actually just means. So where we have 1 here, 1 plus root 3. What rationalization is just you getting rid of this root symbol or root sign here in the what? In the denominator. And you do that by multiplying the numerator and the denominator by the conjugate. So the conjugate, you know that what is just going to differ here is the sign in between. So we have positive here, the conjugate will have a negative. So meaning I'll multiply by 1 minus root 3, then I have 1 minus root 3 there. And this here is going to give me a good outcome. That is just going to be 1 over root 3, like that, 1 over root 3. Then here, observe, so you're just doing normal algebra multiplication, where you have 1 plus root 3, then you have 1 minus root what? Root 3. And we know that when you get that, you just get 1 by 1 by the root 3, then you have plus root 3. Of course, this gives us 0. Then the other one is going to be negative. Then you get what? So root 3 here multiplied by root 3 just gives us a 3. So you get a 3 there. Yeah. So you get this here in your denominator, and you see this is, let's clean this up. You get 1 minus 3. Root 3. Then that will be just 1 minus 3 down there. Okay. Then this, of course, is going to be equal to 1 minus root 3, then divided by that there gives us negative 2. So getting negative 2, I can divide this negative 2 into each of these terms here, which just simplifies to negative 1 over 2. Then that would be plus, of course, 1 over 2 root 3. You can see it like that. So this is what you get here. Okay, yeah. So that's how our answer simplifies to. And part 2, you just do the same. There's no difference at all. Just do the same. So meaning we can go on to part 3, such that we handle part 3, and we continue with that one. So part 3, at any point where you just feel like asking. to ask. So part 3, let's expand. So first of all, for part 3, we have 1 over 3 minus root 2. Then you have your squared there. So you have to evaluate what's down here, of course. So evaluating what's down, observe you have 3 minus root 3, minus root 2, I mean. And that means, and it's squared, so it means it's multiplying by itself. So that'll be 3 minus root 2. So that there can multiply, then that with that, then that with this, then that with that. And we just get the first one, 9. Then multiply by that one, you get negative 3 root 2. Multiply by that one, you just get negative 3 root 2. Then you have plus, then that gives you 2. Then observe when you add there, you get 11 minus 6 root 2. So this is what you have in the denominator. So I can replace that by 11 minus 6 root 2. So after getting that, I can now multiply by the conjugate of what I found. So the conjugate of what I found is going to be, so I multiply by, that would be 11 plus 6 root 2. Then there I have 11 plus 6 root 2. And this, of course, just going to give us 11 plus 6 root 2 in the numerator. And in the denominator, I'm going to get, I know that those terms there, the terms in between here, this negative root 6 when multiplied with okay, so anyway, let me just do it, and but afterwards I'll explain to you a shorter way of getting this. So where we have, so when we say 11 minus 6 root 2, then 11 plus 6 root 2. Okay, let's be here together. So 11 by the 11, what do we get? Let me even use different color. So you're multiplying 11 by 11, you get what? That's 121, right? Right? Okay, guys, are we still here?
Yes, it's 121.
Okay, then the 11 by the 6, that's 66, right? So you get plus 66 root 2. You do the 11 by there, you get again negative 66 root 2. When and if the video cuts, just rejoin using the same link. So that's root 2. Then this part here gives you negative. So you see it gives you negative 6 by 6 gives you what? 36. Then you multiply it by 2. So it's 36 multiplied by 2. And 36 multiplied by 2 gives us what? By 36 multiplied by 2. That should give us 72.
72.
Right. So you have the 121 minus what? 72. Then this, of course, here in between just gives you 0. What is 121 minus 72? What do we get? Anyone? What are we getting there? Uh-huh.
49.
49. Okay, so we get 49. Okay, so it means here we're dividing all this by what? By 49. That's what we are dividing by. Then you see, can you actually simplify this further on when you say 11 divided by 49? Do these have any common denominator? Let me just read out. Not seeing any myself. 49, then you have root 2. Does 6 and 49 have any common divisor here? It doesn't, right?
No.
So meaning you'd have to end here. So this means you'd have rationalized and you'd have done your RCC work like this. Okay, so now the shorter way of how you get this conjugate here is always to say, for example, let's use the 11, the one which we have here. So I'm multiplying it by its conjugate. So what do we do there? So observe that you can say 11 then you square the 11. Of course, always keep the negative sign. Then you say 6 root 2 squared there. And this, of course, when you square, you get 121. Then here you can, when these two, the square distributes. So in short, you're going to have 6 squared. Then you have 2 root 2 squared. Of course, this and that cancel. Then you have 2 multiplied by what? 2 multiplied by 36. And of course, that gave us 75. 72, I mean. Then you get your 72 there. So instead of doing all this algebra here, just square that, and then you get your answer and your value that you wanted there. You do the same for the other remaining questions, and you get the answers there. Okay, then we have this here, and question 13 says, give your answer in the form, this form there, where P and Q are rational what? Numbers. So they told us to give it in that form. What do we do there? We have 3 minus root 3, root 5, I mean. Then you have 5 minus 1. So to get to that form, of course, we multiply by the conjugate, and we have 5 root 5 plus 1 divided by 5 by root 5. Yeah, root 5 plus 1. And of course, this here is going to give us, so on top, you're having this, you're multiplying it by what? By that there. So 3 multiplied by square root of 5, that to be there, 3 root 5. Then you have plus 3, and multiplied by the 1. And you have negative 2 multiplying by root 5. This here frees the 5 from the root, and you just get 2, negative 2 multiplying by 5, and that gives us 10. Then the last part there, you just get negative 2 root 5. Then down there, we know we can square. So I can square 5. I can square root 5 like this, minus 1 squared. And this is going to just simplify to here in between. I can add these values. I just get negative 7 there. Then also this and that there, I can subtract, and I just get root 5. So that gives me root 5 minus 7. Then down there, I get 5 minus 1. Then this here is going to simplify to 5 root 5 minus 7 divided by 4. Then here, I can rearrange this where I when I divide. Okay, let me just rearrange it after dividing. So I can divide 4 into both of these. Then you see that I will have 1 over 4 root 5, then minus 7 over 4. And I can write this as negative 7 over 4. Then I have plus 1 over 4 root 5. And that is the form which they're asking for, saying P should be a rational number and Q also should be a rational number. And I can observe that negative 7 over 4 is rational, and also 1 over 4 is what is rational. And here the root of 5 is the one which is what irrational. And of course, they did tell me my root of 5 should be there. So that's how I get that value there. Okay, so next to the next question. Okay, so this is the next question, and they tell us show that that can be written in the form a, b, where a and b are just integers. So how can we write it in that form there, where a and b are what are just integers? So it's just the same thing that we are working around. So even here, what they're telling us is we must just rationalize this. So how do we then rationalize this? So 75 minus root 50. It's just multiply by the conjugate, 75 plus root 50 there. Then you have 75 there, 75 minus root 50. So that's what you have there. And how do I, what then do I get? So on top there, you just get the 5, of course. So I won't multiply the 5. I'll keep the 5 outside for now and say root 75 plus root 50. Then down there, it's the same as saying I'm just squaring these and subtracting. So in short, I just get 75 minus my 50 there. What's the value that I get when I subtract these two? What?
25.
25.
25.
Okay, thank you. So you have your 5 there, then you have root 75 plus 50 there, then you have divided by your 25. So I see that I can divide this 5 into that there, and I just get 5 in the what? In the denominator there, and I'll just have 75. I have 5 root there plus root 50, then divided by 5. So look at the form which they told me to get. They're just telling me write in the form A over B, like not A over B, in the form where I have root plus. So there's a plus sign there. I have that root there. And I can see the numbers that are inside there are just integers. If I want, I can further on just write it and say root 75 over what? Over 5. Okay, so now my aim is, can I simplify this? So yeah, before we go to writing it in that form is, you check, can you simplify the root 75 by 5? Is there any perfect square there where you can multiply that? Can we multiply that how many times, and if it's there? Okay, so look at here, you have 50, right? So 50, you have root 50 here. Can you simplify this root 50 further on? So root 50, can 4 divide? Let's start with 4. Can 4 divide into 50 here? Without leaving a remainder, can it?
No.
It can't. Is there
No.
any perfect square where we can divide here? There is, right? 25, isn't it? By what? 25
By 2.
by 2. Yes. So 25 by 2. Let me erase this part. 25 by 2. Then for this 75, that is what? Right. So what we were saying is we have for the 75, what is the 75 for it? How is it going to be? Here we said 50 is 25 by 2. 75 is what? 25 by?
3.
By what?
By 3, no?
3.
By
5
3.
by 3, yeah.
Okay. So we have 25 by what? By 3. Okay. So after getting that, so now we see that where the 75, we say you have that is going to give you so you can separate that to say 25 root 3, then that will be plus you have 25 root 2 there, then divided by the 5 which is there. Then now here you see you have square root of 25 just gives us 5 here, then you have 3, then plus 5 here root 2. So you get this, then divided by what? By 5. I can say that I can factor out a 5 there. So there's that 5 there, then you just have square root of 3 plus square root of 2. Then you have your 5 in your what? In your denominator there. And this 5 divides into that 5. Then this just nicely what? Cleans up to whatever they are asking us in our what? In our question. And this just gives us, this will be equal to root 3 plus root 2. And of course, this is our final answer. It's in the form where we have root of A and root of B, where A and B are just integers. So that's how you get that value there. Is there any question? Are we all clear? Are we on the same page? All right, there's nothing, so I guess we're clear. We have this here. Without using a calculator, expand this. We expand the same way we've been expanding. You have root 11 there minus 5. then you have 5 minus root 11. So you multiply this by that there, and of course the same process to continue. So you have 5 there, root 11, then multiply that 2 there, you get 11. Then multiply 5 by 5, that gives you negative 25. Then that will give you plus 5 root 11. And here, what do we get when we add these two here in between? That gives us negative 36, right? So you get negative 36. So you get negative 36. Then you have this there and that there, of which we can add, and that's gonna give us 10 root 11. Okay, so didn't use a calculator or anything, and we've expanded, and yeah, that's where we get. Okay. Okay, I think this is the last set of our questions. The last set of our questions. Write down the value of the following. Now I'm gonna ask you for question 1. What's the value of that? Anyone to tell me what's the value of? So those things you're seeing there, that's just the modulus. So just seeing modulus of 3 over 4. So what's the value of the modulus of 3 over 4? Okay, no one with an idea? Okay,
It's 3 over 4.
good, it's 3 over 4. So everything in the modulus, what's going to come out of it must come out to be a positive value. So where there's negative here, for example, the next one, you have negative 0.2528, I mean. So meaning it's in the modulus. So anything that is going to produce out of the modulus has to be positive. So you get positive 0.28. And you do the same for the others. My focus is, let's go to the last one, part 5, which kind of looks like it has a lot of Tuma modulus that is going on. So you have actually the outer modulus. Then inside that outer modulus, you have negative 2 on top is in the modulus. Then you have negative 3 there, minus 3. Then it's dividing by negative 6 modulus there, minus modulus of 8, like that. Then I'll close the modulus there, which is that part there. So now let me work it out in stages. So inside, so let me keep the modulus that is outside first. So here, modulus of negative 2. What's the modulus of negative 2?
Positive 2.
So you get positive 2. Then you have your minus 3 there. Then, like that, divided by, what's the modulus of negative 6?
Positive 6.
So you get positive 6. And you know, even for 8, we'll get what? Positive 8 there. Then we can close this like this. Then now, what are we going to get on top? Here we will get negative 1. Then down there, when we subtract, we get also, this gives us negative what? Negative 2, right? And this here, what's going to be the value of this?
1 over 2.
1 over 2. So 1 over 2 is going to be the value, and this here is the correct answer. You do just the same for the others, and you'd have finished up with this. All right, so this is where we end with today's class. If you haven't registered, the link has been shared on how to register. It's easy, and you can enjoy these lessons. And if you haven't told a friend, remember, just tell a friend. It's important to share knowledge before things get tough. So you guys keep on solving, keep on practicing. I know you have a quiz soon, so you need to do these questions from the tutorial sheets. Make sure you've understood all of them and you're able to solve all of them. Okay, unless there are any other questions,